Okay, with our intro out of the way, let's actually get started into some calculations. So this sheet with the 5 questions, this is under the module in Carmen. So I'm going to go through these questions. They're going to get you all prepared to actually be able to do the worksheet. So you're going to see there's really just one critical step that makes these calculations different from the seeding rate calculations. And so, I mean, when I've introduced these calculations, I'm doing it strategically because I'm trying to kind of lay concepts on top of each other and the setup of the equations that you'll be most familiar with. So let's look at this first question. How many pounds of nitrogen are in a 50-pound bag of fertilizer with an analysis of 12, 4, 6? And so we have a 50-pound bag of fert, and it has an analysis of a 12, 4, not 16, Zane, 6. Wow, this is starting off real great. And so I'm asking you, how many pounds of nitrogen are in this 50-pound bag? And so we know from the analysis that 12% of it is going to be nitrogen. So if this was a 100-pound bag, we would know it would be 12 pounds, but it's a 50-pound bag. And sometimes the math works out really easy, but to set this equation up, you would want to have 50 pounds of fert, and really you'd just be multiplying that number by 0.12. We know for that 12% of this, for every 1 pound of fert, we have 0.12 pounds of N. So really all you're doing here is 50 pounds of fertilizer in our fertilizer bag, but only 12% of that is nitrogen. So 50 times 0.12 tells us that this is 6 pounds of N in this bag. So the answer for your first question should be 6 pounds of nitrogen per bag. So that's pretty simple. In terms of where you might do a calculation like that, you'll see that I can make these a little bit more complex to where maybe you go into your shop and you see, hey, I've got 8 bags of this particular type of fertilizer. What's the highest rate I could put it out on over all the putting greens? And so you'll see, we'll build on that later. That was a very, very simple one. So let's move on to something a little bit more complicated. The second question, how many pounds of 1925-12 are required to fertilize 7 acres of newly seeded sports fields at a rate of 1 pound of N per 1,000 square feet? So this is the exact type of question you're going to be asked to do, where you've been asked to apply at some rate. In this case, our rate is 1 pound of N per 1,000 square feet. Okay? And the fertilizer that we're using has an analysis of a 1925-12. So this is a starter fertilizer with that high amount of phosphorus. And we're going to apply it to 7 acres of sports fields. And we want to know how many pounds of fert are going to be required. So, real practical question. You know, maybe your boss says, hey, I want a pound of N put down on the field. I want to use that starter fertilizer, and maybe you have to call up the rep and get it ordered, or need to go back there and count how many bags you have to determine what you need. So this is all about determining how much product is going to be required to do the job. And so a very simple way to do these problems is that you have to understand that the product that you actually apply is not all nitrogen, right? We're trying to apply 1 pound of nitrogen, but our fertilizer is only 19% nitrogen. And so there's this concept, I'm sure you did it in Dr. Nangle's class, called rate over analysis. Or I like to remember it as what you want, which is our rate, over what you've got, the fertilizer analysis. And so to set this up, it makes it really, really easy. Our rate in this case is 1 pound of nitrogen. And our analysis, we know our fertilizer is 19% nitrogen. So the rate over the analysis, 1 divided by 0.19, tells us that 5.26 pounds of fertilizer are going to need to be applied per 1,000 square feet to actually achieve our desired rate of 1 pound of nitrogen per 1,000 square feet. So you can see that the pounds of nitrogen, this is like the uniform language. It wouldn't matter what the analysis is. You could get that rate to be the same every time. The deviation is always going to be in the analysis. So this is a key step. Being able to do this rate over analysis part of the problem. Places I see students make mistakes is with decimal points. You'll see in some other examples here, if this would be 8%, it would actually be 0.080. And if this was 3/4 of a pound, it'd be 0.75, etc. So once you get here, 5.26 pounds of our fertilizer per 1,000 square feet of what we need. Now this is just like what you guys have been doing. We want to convert this into acres. So 5.26 pounds of fert per 1,000 square feet converted into an acre, 43,560 feet squared per acre. So I'm going to multiply this by 43.56, and I end up with 229 pounds of fert per acre. Okay, and we're going to apply it to 7 acres. So here my acres are going to cancel. And so I'm going to take this number, multiply it by 7. And you're going to see we're going to end up with about 1,604 pounds of fertilizer. Okay, so 1,604, round up 1,605 pounds for answer 2. So that's a very stock style question. This is exactly what you would be asked to do in an exam. So moving on, let's go to the next question. I'm afraid my marker's going to run out of ink here. The third question asks, how many 50-pound bags of Nature Safe are required to fertilize a 23-acre city park at a rate of 0.75 pounds of N per 1,000 square feet? So Nature Safe is a poultry litter based product. You'll see it has an analysis. It's an 835. This is a slow release nitrogen source. It's a poultry litter, so it has a pretty formidable smell to it. And we want to apply it at a rate of 3/4 of a pound of nitrogen per 1,000 square feet. Okay, and we're going to fertilize 23 acres, and we want to know how many bags. How many 50-pound bags? So again, just like the last equation, we want to start off with our rate over analysis, right? And so what's our rate in this example? We're going to have 0.75 over our analysis. And this is a place I could see students make mistakes. They're going to want to put a 0.8 here sometimes. Again, 0.8 would be 80%. We know it's only 8%, so this is actually going to be 0.08, okay? So 0.75 divided by 0.08. We're going to have 9.375 pounds of fert per 1,000 square feet. Okay, so this is how many pounds of product, almost 10 pounds of product, are going to be required to actually apply 3/4 of a pound of N. So in this example, I asked you how many 50-pound bags are needed to fertilize 23 acres. So let's get this converted into pounds of fertilizer per acre. I'm going to multiply it by 43.56. I'm going to end up with 408 pounds of fertilizer per acre. Okay, we're going to fertilize 23 acres, so 408 pounds of fert per acre times 23 acres. So 9,393 pounds of fert to do all the fields. One bag is 50 pounds. So I'm going to divide that by 50. I'm getting 187.8, so I'm going to round that up to 188 bags of fertilizer. Okay? So, think about that practically. 23 acres of turf you got to do, and you're going to unload 188 bags. That's nearly 4 pallets of fertilizer. And so you can see with these low analysis fertilizers, it ends up actually being a lot of material. Sometimes that's desirable, other times it's not, and we'll get into that in this class. So I'm going to pause there and make sure that the video is still indeed going.